Air Force Program 675 was manifested on the first space shuttle mission scheduled to fly out of Vandenberg Air Force Base in mid-1986. The objectives of the program are, first, to provide an opportunity for high-priority Department of Defense research and development payloads to obtain data, and secondly, to explore the opportunity that the shuttle and its crew offer for enhancing data collection and reducing costs. Lockheed is the prime contractor for the AFP 675 effort, which is managed by Space Division's Space Test Program, YC. 6 payloads are assembled on the experiment support structure, which is depicted in the upper left of the screen. The command, control, and data evaluation functions are provided by the shuttle crew, who use a specially developed computer on the aft flight deck of the shuttle to accomplish this task. Lockheed's major responsibilities for the program are listed here. The space vehicle occupies 1/4 of the shuttle's cargo bay. The unique feature of 675 is the complete autonomous operations of the vehicle by the shuttle crew. These are the 6 experiments that are carried. The space vehicle was tested at Lockheed's Sunnyvale facility. A test fixture supports the space vehicle in a vertical position as it would be in the shuttle cargo bay on the launch pad. The objective of the prime experiment, the Cryogenic Infrared Radiance Instrument for Shuttle, or CIRRUS, is to gather information on the structure of the atmosphere. The central telescope is located inside a 2-axis gimbal system, and all hardware is covered by white thermal control material. All data is stored on tape recorders, which are in pressurized containers located on the side of the space vehicle. The quadrupole ion and neutral mass spectrometer, QUIMS, is mainly used by the crew to determine if the shuttle environment is sufficiently clear of contamination so that the CIRRUS cover may be opened. FAR-UV consists of 2 film cameras mounted on an A-frame structure, which allows the cameras to be gimbaled by the crew using a manual pointing controller. The object between the 2 cameras is a low-light level TV camera, which allows the crew to view exactly where the FAR-UV is pointed. The Gamma Ray Advanced Detector is evaluating the use of new materials to detect gamma rays. A liquid nitrogen dewar surrounds the instrument. The Horizon Ultraviolet Program instrument also evaluates the Earth limb simultaneously with CIRRUS. The device pivots as it collects data. Also seen at the top of the picture are the payload support structure members, which provide an interface to the space shuttle. Located at the end of the space vehicle, the uniformly redundant array is topped by a celestial aspect film camera, which will provide precision pointing information for post-flight data evaluation. The objective is to test a new X-ray detection technique which employs an aperture, shown here, which has 256,000 pinholes. Data collected by all experiments except CIRRUS will be stored on a space vehicle tape recorder for post-flight analysis. The silver cylinder engaged in a black latch on the right side of the screen is one of 4 trunnions that attach the space vehicle to the orbiter. Here we see the CIRRUS gimbaling. During this operation, the shuttle would operate in a nose-down gravity gradient attitude, which will have CIRRUS pointing at the Earth's limb. All possible sources of contamination will be inhibited from operating during this time. The gimbal motion can either be pre-programmed to collect data in a prescribed pattern, or the crew can use the manual pointing controller to align the instrument to collect against the aurora borealis or to respond to anomalies. The objects on the far side of the telescope are low-light level TVs, which allow the crew to know where the instrument is pointing. During operations, interferometric, and radiometric data are collected to build a database on the spectral and spatial structure of the atmosphere at varying latitudes and under changing solar illumination. The cover on the end of the CIRRUS telescope must be opened prior to data collection. Here we see how that would occur. Because of concern about possible contamination of the optics within the telescope, the cover opening mechanism is detached from the cover, which is the silver section. Here we see some of the shuttle flight crew discussing a flight data file procedure. There are 7 men in the crew. They are mission specialist Mike Mullane and Jerry Ross and payload specialist Brett Watterson. Not present are crew commander Captain Bob Crippen, pilot Lieutenant Colonel Guy Gardner, mission specialist Commander Dale Gardner, and payload specialist Undersecretary of the Air Force Mr. Aldridge. Here we have Colonel Mullane conducting a test of the responsiveness of the pointing and tracking capability of CIRRUS using the manual pointing controller. Upon completion of this phase of testing, the space vehicle was returned to a horizontal attitude and all experiments were subsequently removed and returned to their sponsors to await a new shuttle launch date. Let's take a moment to examine the structure upon which these experiments are mounted, the Experiment Support Structure, or ESS. This is the short equipment section which contains most of the avionics of the ESS. This section is thermally controlled and provides protection against the acoustic environment at launch. Capabilities include distribution of power from the shuttle to the experiments, and also relay of commands from the crew to the experiments, and the routing of telemetry information to the tape recorders as well as to the command and monitor panel on the aft flight deck. Now that you've seen what will fly on the shuttle, let's take a brief look at the factory test support system. No, we're not building a gold-plated spacecraft. That's the thermal control blankets. In order to prepare the flight crew and other flight operations personnel for the mission, a new facility was constructed, the Simulation and Training Laboratory. This is where we develop the crew operating procedures, validate them with the specially developed computer that the crew uses on the aft flight deck. That computer is called a Command and Monitor Panel, or CMP. Then we train the flight crew on the procedures, and finally, the laboratory is used to support readiness exercises. In the foreground is the instructor-operator station where the training scenarios are created and malfunction information is interjected into the exercises. In the background is an aft flight deck mock-up which contains the command and monitor panel and the monitors where the low-light level TV signals from CIRRUS and FAR UV are displayed. The CMP has a keypad to enter commands and a CRT for validating commands before execution as well as display of telemetry data. The cable is where the manual pointing controllers are connected to the CMP. These are examples of information that's displayed to the crew. All of us at Space Test Program and Lockheed hope that this presentation has been informative.